at it. But as you see today, we use both AC and DC. You got DC inside your cars and your car battery. Any battery, that's direct current. Okay, but inside our homes, when you got 3-prong plug, that's AC. Because you got one prong that's going to connect to that hot, you got one prong that's connecting to that neutral, and you got that one at the bottom that connects to your ground. And that's called your equipment ground. Anyway, back to our equation, and then we'll transition into talking about what we're going to do today. Say you got 2,600 watts, and you know your volts are 120. Using this equation, I can determine how many amps I'm going to be using, right? Basic algebra. Watts equals volts times current. A watts equals 120 times my current. What do I do? Just divide through, and that gives you something close to what? 20 point something amps. But math specialists out here.
It's 2 points.
Well, yeah, what?
Or 2, I'm sorry, maybe it's, no, it's...
No, that's right, you're right.
What's the question? 120 divided by 2,600?
20.
So about 20, is that right?
Yeah.
No, it's side. About 20 some amps. Just to give you an example. Alright. Now, let's talk real quickly about the most important thing in electrical work, or any kind of electrical anything. And anybody tell me what that is?
Safety.
Exactly. Safety.
That's why I never touched it.
Absolutely. Safety. Always work with a wire like it's hot, even if you know it's not. What we're doing today, we won't be connected to any power source, so we won't have to worry about that. The only potential hazard is this panel, because as it's sitting there right now, it's absorbing the light, and it's got a module on the back that we wire up to that's collecting that energy. So it's energy sitting on that right now, but we're not. I'll probably have to deal with that myself. So safety. Even using tools, make sure you use eyewear when doing any drilling. Don't break up anything. Make sure you use gloves. Make sure everybody around you is always aware of what you're doing. Common sense. Keeping our space clean. We're going to be on ladders. Ladder safety is very important. I break that rule a lot. Don't ever stand on the top rung of a ladder. But you know, sometimes you gotta do what you gotta do. Somebody's on a ladder, should be somebody holding the ladder for them. Basic CPR. If somebody touches an electrical circuit and they start getting shocked and they can't do nothing to move, the last thing you want to do is go up and say, "Hey, you need some help?" Because now both of y'all gonna be standing there.
You gotta push them off.
You gotta push them off, but don't go grab a metal pipe and do it. Get a piece of wood. If you can kick them and, you know, kick them off or something like that. Unfortunately, I've never had to deal with that situation. I have been shocked before, but I was able to get off of it. So yeah, that's that. Any questions? Any questions? All right, so let's talk about real quick basic components of our solar system. And a lot of this is going to be on the website when y'all go, and y'all can see a lot of this in a little more detail. We got sun energy coming here, and it's hitting our panel. Now mind you, the sun, each of these photovoltaic receptors here converts this sunlight into DC current. And then we take a wire and we run that to where we're going to run it, and we interrupt that path with what we call charge controller, and that does exactly what his name says. Controls the charge, lets you know let's continue with it. Once you come off that charge controller, you could run straight to your source, say if it's a light, but that means that your light is only going to be working for as much sunlight is being converted in any given amount of time. So normally what we'll do from there, we got to have a means to store it. And to store it, we use a battery. Okay, so it's coming off your panel to your charge controller. Charge controller reads how much energy is stored in your battery. It regulates. It also prevents power from leaking out this way, because at nighttime panels have a tendency to give energy back off to the cosmos, which only makes sense. It's got to be it's got to be some kind of reciprocal flow, and it also prevents too much energy from overloading these batteries. Keeps it from overspilling. So it'll cut this off once this battery or your bank of batteries reaches capacity. Make sense? Yeah. Okay. Coming off your battery bank, you're gonna run to what is called inverter. Many of you maybe have used these. You can use them in your car. If you've ever been on the boat, you can use them on your boat. And it basically converts DC to AC. Simple enough. That's all it does. Comes off your batteries, hits your inverter, converts it to AC. A lot of inverters will have a plug on it, so you just plug right up right here. Put your VCR, whatever you want to put on it. Food for thought. If you want to convert AC to DC, you use what's called converter. Okay? Alright. So then from here off the inverter, we will have our load. And in this case, we got a ceiling fan we're going to put up. We're going to mount 2 ceiling fans right here.
Solar panel.
They got lights on. Okay. Let's see. Only thing I didn't put in here is your overcurrent protection. Overcurrent protection is very important. You may know it as a fuse or a circuit breaker. Overcurrent protection prevents
Solar chain.
or it opens the circuit in case of overloads or a short circuit. If these wires accidentally touch, the overcurrent protection is supposed to open the current and protect personnel and your equipment. So normally we'll put some overcurrent protection here, and it's also good to put some overcurrent protection here to protect your inverter. And the inverter has built-in overcurrent, well, not overcurrent protection, but it has a built-in disconnect. Disconnect is just a switch, disconnecting the power. Alright, so that being said, any questions?
That sounds like a lot in 10 minutes.
I know, man. I'm laying a lot on you. I'm laying a lot on you.
We're going to have a quiz on every single concept on that on Wednesday, so be ready. No, I'm just joking. That's really more just a crash course, so you can get an idea of what you're doing, but like he said, it will be on the website where you can kind of study it more, but really just to get you familiarized with the concepts. We're actually working on now having a solar class. It'll be a 3 to 5 week class just on solar alone. So you're getting a crash course of a 3 to 5 week.
Do you already have your residents, or I mean your participants? Your participants?
No, we still in the process of organizing everything. It'll be out. You'll hear about it.
My man.
You'll hear about it.
All right. So now let's talk about what we're doing today. We're gonna have several things. Overall, the main thing we're gonna do is install solar panel. Okay, that's gonna be on the roof. We're gonna put it on the roof here. I gotta resist the temptation to keep going and tell you information about how it's best for the panel to face south, because it receives most energy when it's facing south at mounted at a, I believe it's what, 40 or so degree angle. I guess I told you anyway. We're going to install the solar panel.
And really it's more, you see the panels that we have here, they're south facing.
Right.
These won't be south facing, but the good thing they will be facing east. So that's why they call it South Face Institute. Yes, if you've heard of South Facing, that's why it's called the South Face.
Never knew that.
The sun rises from the east, but it's southward facing.
Right.
Or northward facing, so you want to have it south. Yeah.
We're also going to have to build what we'll call it a trapeze. It's kind of a, jargon that we use in the field. Trapeze is something that's going to hang down that you can hang your components in. We'll build a trapeze for our photovoltaic system, which will include batteries, inverter, charge controller, and any overcurrent protection. Okay? We're also going to mount our fans. So I'm going to have some of you getting our fans assembled and ready to go up.
What's the CCM thing?
Charge controller. And we want to install an outdoor GFI or outdoor outlet that we can plug into, but it's going to be powered off of the system, the existing system. So that's going to be a whole nother project that's going to involve trenching, because we want to bury our conductors running from our system in there to an outlet out here. Okay, trenching for outdoor receptacle. What was that word I said just a second ago to call it a receptacle? GFI. Anybody know what that is?
Well, it trips off or it gets overloaded. And you have to go and push the button.
That's exactly what it is. And now what it does is it recognizes any minimal, very small imbalance between that hot and that neutral, and it shuts itself off. You find them in your kitchens, you find them in your bathrooms, and you find them outside.
So what is that?
GFI.
Yeah, I mean, what's the...
Oh, I'm sorry. Ground fault. Sometimes you see it. GFCI, ground fault circuit interrupter.
It's like a socket with the red.
Exactly. And inside that outlet, it's normally in a square like that, And you got a button here that says reset, and you got a button here that says test. Right. And it's got on the inside some sophisticated circuitry that's always measuring that current and the unbalanced load going back off the neutral, and any kind of variation shuts itself off immediately, protecting you. Now, what I recently learned, I find it proper to tell you that in your bathrooms, if you're in the sink, you're shaving, or ladies curling your hair, whatever,
right.
You're plugged into one of these GFIs, and you got your sink here running with water. We know water and electricity are gonna mix, but don't think because you're plugged into a GFI that you can just go and do something real, crazy. Always just remember that with electricity, these are not 100% foolproof, is what I'm saying. And they teach us like they are, but they're not. Okay. So, those are going to be our main projects. We're going to divide ourselves up into groups here. I think hey, Brother Kashawn, is just you and I today? Brother Chen is not?
He's going to be here a little later.
A little later? Okay.
Probably around 5.
Okay. Now, most times on a job site, you have a guy who's pretty much kind of like the lead guy. Then you have, foreman. Foreman doesn't